Assalamu alaikum, and today we discuss about this homogeneous transformation. This homogeneous transformation, I will share with you my teachers with uh, those slides has provide, and also uh, with pointer he has taught me, and just I want to describe, and also I try to indicate that that's important, and also critical point which is to know very important for students to solve this problem. Okay, let's start. And here in type of joint, there's two type of joint here is the prismatic joint and regular joint. This one the prismatic joint, this one prismatic joint, and that one the regular joint. If we consider the cylinder and this angularly moved, this is the regular joint. And link, we know whatever in the prismatic and regular joint that will attach with the link, that is the link. Here is the link length, and manipulators. That link length is all together is called the manipulators. And rotational matrix, obviously, and when all manipulators will rotate on move with angularly, then we can say that is the rotational matrix. And actually rotational matrix indicating the is the vector link diagram, and also the identification of the exit joint. Okay, start and go next. And here is homogeneous transformation matrix. Is homogeneous transformation will be here. If you consider the is denoted with ace is homogeneous, then was the rotational matrix, and that is the displacement matrix. With these two matrix, we also have to add some portion like 3 0 with rotational matrix and 1 with the displacement matrix, and then 3 rotational matrix with will 3 0 in horizontally in last portion, and displacement matrix in lower side, lower portion will be 1. Then we can make, or we can say this one will be homogeneous matrix. Also is vector. Vector we know is to in the magnitude and direction when we denote in this axis, and x-axis and y-axis, and between this x and axis in diagonal line indicating this is the this inclined line or diagonal line is indicating, and the a is cos theta and a is sin theta, and between theta degree angle. Okay, and next one is the, and this kinematic this homogeneous translation matrix, for we have to know this is a transformation, how it going through. Is it revolute, is it prismatic? We have to know from structure. Okay, suppose this is given this, at first we have to write down this is indicating the first one in the this 0 coordinate system. We are denoting, we are considering 3D. Okay, and 0 and x1, y1 and z1. This theta 1 indicating the displacement coordinate system 1 with respect to 0, and also a1 is the link length. Link length is actually is indicating the link 0 to 1, link 1 distance with respect to 0 coordinate system. And also here, and the second one is coordinate system 2, coordinate system 3, 2, and coordinate system 3, and coordinates, okay, 1, 2 and 3. And here, and also important thing that how we'll understand this is the this is x-axis and that is the z-axis. We have to remember is uh, in z-axis will be that with with one axis will be revolute or rotating. That axis we have to find out and we have to denote that axis is the z-axis for revolute joint. Okay, clear. And x-axis, this x-axis will be freely independent to we can give here and also we can here, but here we have given we have denoted the x naught from that we use the right hand rule that will go in the y naught. Okay, that will go y naught. That means find this out we have to denote that. And another here is displacing, this is the also is rotating, is revoluting joint. For revoluting joint is rotating, we're looking here this angularly theta 2-degree angle is producing here. There is no any displacement in z-axis and only displacement in the x-axis, and this x-axis will be perpendicular with respect to z-axis. Okay, and if we get this x1 axis and by using the right hand rule we will get the y1, and if we get the y1 and this means third one will be the z1. It's clear. And another is the link length is the y2. Y2 actually is the this coordinate system to one coordinate system to two coordinate systems link length, and like same is the prismatic joint. And another is important thing we have to remember that which away will be displaced in prismatic joint, and that portion will be the z-axis. We'll get the z-axis z2 and x-axis and y-axis, and y-axis and z-axis actually is perpendicular y-axis and z-axis, and y x2 will be the axis in the vertically. Okay, then and if we consider this z1, if we rotate this away, rotate this away, that means the z2 this has gone in that place. That means obviously in x will be in upside, that means in here has vertically and is horizontally here staying, and after in second quadrant system it will go in vertical direction if we imagine the rotating this coordinate. And this is the in effector and is copy of before joint just, and obviously here will be denoted d, that means displacement factor. Okay, as d is the 0, and this means 0 0 only z-axis remain, other is 0, and we here 0 1, that means 1 with respect to 0, 1 with respect to 0, 0 d 1 2, that means 2 with respect to 1. Here is the rotating and displacement there is no any displacement in z-axis, that means z is 0, and is displacement in angularly. If we consider this is diagonally, that means here will be both and x and y and cos and sine, this x and y. And d 2 3, that means 3 with respect to 2, there only displacement in the z-axis, others is 0, and with displacement d, because a3 is the fixed, but d can move in here there. For this region we can say this displacement will be A3 plus D3 is the displacement and rotational matrix. That means we have two rotational matrix that is rotating in the z-axis. That means we know in before in previous slide in kinematics we know kinematic matrix, we know that when it rotates on z-axis, z-axis will be this way 0 0 1, and others is the memorizing thing is rotating in z-axis r z. Okay, if you are in query you can see in my previous video in what's my previous video in kinematic matrix. And another is this one is the is we also there we know the it will change by this way x1 y1 z1 and x0 y0 and z0. By this way we have to and also in that video I have cleared that, and thus multiply and we'll get this. And homogeneous matrix for also in this the rotating matrix. This is the all are the rotating matrix, and this is the displacement matrix, and this one the extra part for doing the homogeneous matrix. That means 3 into 3, and in previous slide we know that 3 into 1 3 into 3 1 and 0 0 0 is 1. That is the homogeneous matrix. And after that and final in factor where will be that the 0 3 with respect to 0 just multiply all are that this one will be 0 with respect to 1, this one will be is 1 2 and that one will be 2 3, and all are multiplied, we will get the 0 to this one. I think is clear to you. And next one is the same procedure, just is your homework, and by this way we will get this answer. I think though you have confusion you can write in comment section. Also you can watch different type of video and online is available. Thank you for your patience. Thank you.